Let's work on some questions from straight lines. So the first question that I'm picking up is about parallel lines. The lines p into p squared plus 1 times x minus y plus q is equal to 0 and p squared plus 1 whole square into x plus p squared plus 1 times y plus 2q equals to 0. They are perpendicular to a common line for what value of p? That's what we have to figure out. So is it exactly two values of p, more than two values of p, no value of p, or exactly one value of p? So let's just figure this out. So guys, you're given two lines which are perpendicular to the same line. If these two lines are perpendicular to the same line, what does it, pictorially mean to you? Well, I guess it's going to be something of this sort. So you have a line, and these are two parallel lines. If they are two parallel lines, so they're like straight 90-degree lines, right? So which means that two perpendicular lines. So these two lines, the equations that have been provided to you, these two lines are perpendicular to a common line. So which means that they will be parallel to each other, because perpendicular means 90 degrees. So both are 90 degrees. So that means they're parallel to each other. And in case two lines are parallel to each other, that means the slope is the same, right? The slope is the same. So slope of line 1 is same as slope of line 2. Now, the slope of line 1 is minus p into p squared plus 1 whole thing upon minus 1. You can check for yourself. So it is minus the coefficient of this upon the coefficient of this, right? So minus the coefficient of x upon the coefficient of y minus a by b. So similarly here, minus p squared plus 1 whole square upon p squared plus 1. You just have to solve for this equation. That is it. So, which essentially means that, let's cancel things here. So, of course, p squared plus 1 p squared plus 1 goes off from here. P squared plus 1, p squared plus 1 goes off from here. So, what do we have here? So, minus goes off from here. So, what I get is that p is actually minus 1. It's a unique value of p. So there's just exactly one value of p, which is giving us, which is solving this situation. So D should be the correct answer. Number 4 should be the correct answer. That exactly one value of p is satisfying this situation. So what have we done here? What we have done here is that you were given two lines, and the two lines are perpendicular to a common line. If they're perpendicular to a common line, that means they are falling off like this, 90-degree slope on this common line. So these two lines that means definitely parallel to each other. If they're parallel to each other, the slope is same. Of course, it's 90-degree if we talk about this line. So if their slope is same, we know the slope formula. We will use the slope formula and equate it, and that will give you a value of p. Next question. A straight line through a fixed point 2, 3 intersects the coordinate axis at distinct points P and Q. If O is the origin and the rectangle OPRQ is completed, then locus of R is, okay. You have 4 options in terms of, the line. 2x plus 3y equals to xy is the locus. 3x plus 2y equals to xy is the locus. Or 3x plus 2y equals to 6 times xy is the locus. Or 3x plus 2y equals to 6 is the locus. What is locus? question arises, what is locus? Locus is essentially, it's the set of points. It could be, a line segment. It could be a curve, a surface. It's a set of points whose location satisfies some conditions. It could be one condition or more than one condition. So we are interested in the locus of the point R. Suppose the point R is h comma k. So let's talk about the situation that we have. So we have a line PQ which passes through 2, 3. So this is 2, 3 somewhere. This line passes through. It's PQ. It passes through 2, 3. And we are completing the rectangle. We are completing the rectangle OPRQ. So please look at the directions OPRQ. Okay. So this is how it will go. So P is here. Then R is here. Then Q is here. This is the lines. This is the line passing through 2, 3. When it cuts Y here, Y axis here, this you get Q. And when it cuts the X axis here, you get P. Now, if the point R is H, K, it's a rectangle. So the relation is such that this point, because this length has to be equal to this length, and this length has to be equal to this length. So the point is such that P will be H, 0. Of course, it's x-axis, so Y is 0. So H, because it has to be the same as what you have for R. And this point is 0, K. Now, what the situation is, we're interested in locus of R. Locus of R means that all the points that will satisfy the condition that R is also satisfying, right? So what are the conditions that we get from here? So first of all, what we can get is equation. Please try to understand when we say R, we're talking about H, K. What conditions H, K will satisfy? So we have equation of PQ. Clearly, equation of PQ is, it's going to be X upon H plus Y upon K equals to 1. Equation of PQ would be X upon H, Y upon K equal to 1. Now, what else is happening now? PQ passes through, this line PQ passes through, So, all the X, Y's which are passing through, when you have X here, Y here, that means you're talking about whatever value of X and Y will be there on this line. So it will satisfy this equation. Now PQ passes through 2, 3. PQ passes through 2, 3. That means X2, Y3. So you get another condition, that is 2 upon H plus 3 upon K equals to 1, right? 2 upon H plus 3 upon K is equal to 1. So now what have you actually got? You've got a condition of H and K. H and K, which is H is the x-axis value, Y and K is the y-axis value for R. H and K satisfy this equation, right? So in other terms, when I want a generalized, in terms of generalized XY, the equation, the locus basically means satisfying this condition. Point R, that is H, K, satisfying a condition. This is the condition it satisfies. So in a general form, you can write 2 upon X plus 3 upon Y equal to 1 is the locus of R. Is the locus of R. Or in other words, if you take the LCM, you will get 3x plus 2y is equal to xy. So what do you have? Do we have this in the options? 3x, 2y is equal to xy. It's option 2. So this is how you find out locus. Locus is basically the set of points satisfying a certain condition. This time the conditions were associated to the point R. So R point I've taken as h comma k. So what is the property that h comma k is satisfying? That is what we have found out in a generalized form. When it is in generalized form, you will give an answer in x and y.